calculations to the level of
You're like an 8th grader in math 1. No, you're an 8-year-old in math 1.
Where does 8 come from?
He's energetic, he's exciting. But then you also have the part that's like, hey, all you guys shut up.
But I like analyze situations and I try to put forward like tough questions to answer. And I don't know that 8-year-olds do that. Homework, plan book. What do you argue? What? What do you need help with?
Asking what bisexual is.
Quincy said he was bi, and I was really confused.
So.
Like, I know what it was, but apparently it's different than what I thought it was.
Okay. Do you need clarification or are we good?
Yes.
Yes, you need clarification?
Yes.
Okay. So the problem is bisexual has a very broad definition. It essentially, if we're trying to like not box it in, means that you don't really like you're not just attracted to one gender, which that then means back when bisexual was a more necessary term, gender was pretty just like male or female. I am one of like people didn't really have the opportunity to like self-identify or different things like that. So really now it kind of means its meaning is kind of even more complicated because if I am, so let's hypothesize this out, right? I'm not actually talking about me, but if I'm a male who likes someone who's identifying as a female, does that make me straight? Or if I'm a male who likes someone who's identifying as a male, does that make me gay? Like, it's a much harder question now because people are like self-identifying their gender. So back then it was because we were more fixated on like, what is your hardware? Right? Like, what does your body have? That's your gender. Yeah. And now it's a bit looser, broader, kind of more open categorization. So really, the answer is it's very complicated. But if that is what people want to call themselves, then that is fine. Like, it's not up to you to determine those labels. That's up to people themselves.
Is Greece Gopher here?
Is what? I had no idea. He's absent.
Were we talking about like pronouns or something?
Well, we were just like trying to define bisexual, but it's very complicated actually.
Chris is here, even though I marked him out.
Is he bisexual or something?
He was like 15 minutes late to
Okay, here's really my my opinion on the whole situation. You're too young to need to make this decision. You don't have to figure this out right now. Nobody should really be asking you to figure this out right now. So quit putting pressure on yourselves to make these choices. I didn't even get kissing until I was like 12. Yeah, I know, it was a different world back then, but for real, quit putting pressure on yourselves.
I kiss my mom all the time.
Well, okay.
That's not.
I didn't kiss somebody who was outside my
family circle. Well, I'll miss that cousin.
He was super
Why
nice.
are you
He was super nice.
Why have you kissed your sister?
I kissed
Satya, there are some things that we can internalize. Kissing your cousin.
Satya, please don't lose this as soon as you like possess it.
Where did it go? I didn't get one.
Alright, put your name on this, please. We are doing more investigation today, and a little bit of it, we're going to act like I didn't teach you about trig yesterday.
There was no trig on the homework.
I know, because we haven't taught you trig yet, quote unquote.
You don't know how happy I was.
So,
Oh my god.
I was quite a bit of excited clapping.
gross. I would not put food directly on the desk unless you've wiped it off. I would just like put a tissue under it or something.
Like, maybe talk to
Middle schoolers in general are gross, let alone I said 2 classes
Dude,
of 7th
Satya,
graders.
he used to pack, and he would put a sandwich on the lunch table.
Oh, God.
Dude, you guys possess so many
What's
germs.
clean the tables?
Yeah. So picture back to yourself as a 7th grader cleaning the table. Yeah, can we talk about that? How about 8th grade steps up your game a little bit?
We clean
All right.
Every other day.
Are we ready? Are we ready? Are we ready?
Yes.
I would like for us to be ready because I think I can probably give you guys some time for homework.
Okay, yeah,
Ready, Eddie. All right, so we're going to connect slope ratios to some approximate degree measures, right? So we looked yesterday at some situations where we said we're pretty close. And I think it was Richner or somebody stayed after class and we were discussing if we actually do the technical trig, how far away are we? And we were within a degree on both of the ones that we did yesterday. But now we're going to look at some situations here where we've been given pieces of the triangle. So like in 78 and then 79, I think is like the whole paper here, essentially. In 78, we're given our 11-degree angle, and we can reference our trig table, graphical organizer here, to the triangle that we had yesterday. Right, so our base triangle 5 with a degree of 11 then had a rise of 1 because that slope ratio of 0.2, right, or 1/5, had an approximate degree measure of 11. And I think when we actually calculated it, it was slightly over 11, but that's okay. We're working approximately here. So using this, figure out your y here. You should need like 4 seconds. How does this triangle compare to...
It's 11 degrees.
I did that on purpose, Thomas. I appreciate that you noticed that. This would be 4, right? So if we relate similar triangles, and we say when I had a base, that's probably not far enough. When I had a base of 5, that was actually 1. Then if my base becomes 20, it's just 4 times. Right, so please go ahead and look at 79 and this table. And try to fill in these missing pieces based off what we talked about yesterday. Sorry, actually, this is not. I forget what this is for. There's nothing specific. This is just so we can put things on here. So we have one organized reference part. So like, see how this is 22 degrees? We could then put this on our table here. So you could make a sketch of the triangle for A in the 22-degree slot. So what I would advise, if you're going to make this worthwhile and help like save you time, is over here, sketch the triangle from the problem that it's giving you, which is what, 25 base, 22 degree.
Oh. I see. So it'll just be 2 over 5.
So we assume this ratio is approximately 2 over 5 when simplified, which means that if it's actually a length of 25, approximate height of 10, potentially?
Yeah.
What unit is this?
Oh, yeah.
322.
Never mind. I forgot about that.
Now if we bump back to the lesson, we have another 11 degree. What would x be here if we have an 11 degree with a rise of 100, Thomas? 500, right? Because our run is 5 times the rise.
Oh, I see.
So these don't all have to go on this paper. We're just practicing this like similar triangle skills, essentially. A 45-degree angle, though, this should be easy for us. Our other leg would be 13. If I have legs of 4 and 4 adjacent to the 90, then this is, of course, going to be 45. So we can go ahead and on our trig table fill in that we know for sure this is 1.
Wait.
Right? This ratio, whatever it is, n over n, has to be the same. So you could sketch yourself a little picture here of a 45, n leg, n leg. Whatever the number on the one leg is, it's the same number on the other.
Does this only work like 90-degree angles?
I was gonna ask.
They're right
that.
triangles.
Yes. Does this
I
only
saw
work?
this
No,
right.
Right.
No,
triangle.
right triangles.
So trig is
Wait.
only with right triangles.
Oh, yes. But you can make any triangle into a right triangle by dropping an altitude. So, yes, with an asterisk of we can force it to work in other triangles, and then you can remove the altitude and manipulate the rest of that triangle.
So we manipulate force and put onto others. Wait,
Sure.
can I demonstrate something?
No, not if it's going to be force manipulation and all those things.
No, physically.
We're going to move on.
Number 4.
Yes, sir.
Now wait.
Yes, ma'am.
Wait, according to our little rule from yesterday, using this reference triangle, how's 55 compared to 11? Times 5. So wait, would that slope ratio be 5 to 5? No. It gets a little funky.
A lot. It's not exactly 11.
What if I have a slope ratio of 2 to 5, or 20 to 50, but reduce that 2 to 5? What do we approximately think that theta is? 22, right? Close to it. Which Chris and I found out here. Was it you that said? Yeah, like Chris and I found out yesterday was actually like 21.7, we think. And here, well, they give us one angle. Well, two, really, because it's a right triangle. Anyone able to solve this one?
Wow.
Once you see it.
One. Or no, it's not one. It's 11.
Oh, I see.
Oh, what? Okay, so this,
Oh,
sorry,
I
this
see
is
that.
11. But what does that make B?
Oh.
35, right? Because the base is 5 times the height, and if I manipulate it, if I turn it, right? So triangle sum theorem, or triangle angle sum theorem, but always 180, right? I can find out that my two angles in the right triangle are going to be complementary. Any? Thank you. This is one of my favorite bow ties. My other one is one that the team got from Italy, the blue one with the bikes on it.
Wait, team?
The team, the team that went to Italy.
Call them the teacher. Never mind. Call them the teachers.
Okay. So we already figured out what Sheila was talking about because we're at the advanced class and we know these
Oh,
things.
Sheila is not.
So wait a minute. She does this same thing with an angle of 68. So wait. So we use this, but if I go back to my resource page, I have a 79-degree angle on my resource page.
So it's just 11.
So what would this slope ratio be?
That'd be 5.
5.
No, just 5. Yeah, just
5 to
5.
1, right?
So just be 5.
So 5.
That would make sense. I guess.
Potentially. I mean, yeah, we're not testing these things. We're just making hypotheticals.
I wish we had more space.
If I look at 68, well, its complement is 22. So my 68 slope ratio, well, what was my ratio for 22?
2/5.
2/5 approximately. So this would be like 5 halves. So what should my x be? Scale it up.
Hold on. Chris, don't think I was gonna get
2.5.
Oh, yeah, I was thinking 12.
12. Yeah. Because to go from 5 to 30 is times 6. I gotta scale this up by a scale factor of 6.
What am I doing?
Sorry, scale factor of 6, this becomes 12. 6 was stuck in my head, and I said that, or I wrote that as I said it. Scale factor is 6, right? But either way, 5 to 2, that's my slope ratio for 68, so I got 5 to 2 here for 68 degrees.
5 to 2 equals
2.5, right? So my slope would approximately 2.5. Because we don't know that that's perfect.
Wait, should the triangle be 5 too?
If your base angle, like here, is 68, this will be 2, and height will be 5. And if it's scaled up. No, because this is going to be wrong.
Wait, what?
This is just to practice our skills of manipulating.
How is this not on our test?
Because it's not perfect trig.
Logic.
This is approximate trig. This is from what we saw from the Leaning Tower of Pisa and all the stuff we did yesterday. we're just extending everything we did yesterday, except for I didn't teach you tangent yesterday, right? So we don't know tangent yet.
So we're doing this all for nothing.
Not for nothing, to make sure that you understand how to manipulate these triangles, find complementary angles, find the unknowns when we manipulate from a similar. We're just practicing our skills. So yes, we are going to move beyond this, and
So this isn't trig.
it's kind of tricky. So
This is trig.
this is
Santi, I think you're like level 1. It's like level 10.
no. So this is level 1. Yeah, level 1 of trig. So here's
This is like a tutorial.
here's why we're doing this, because I really don't like for you guys to think that we did something for nothing. The basis of trigonometry is utilizing the fact that, one, we're operating in a right triangle. There is a perpendicular relationship that we know for sure. Two, the numbers that we're using come from the perpendicular pieces. And three, every triangle must add to 180, and in right triangles, we only care about two angles adding up to 90 because we know the third one. When we put those three things together, we have trig, essentially, if we're trying to simplify it out. So the point of this is to get you to realize trigonometry is just a result of knowing a lot about ratios and how they relate to then their angles. So this isn't wrong, it's just rounded, right? The 22 is not actually 22. It's like 21.78 or something like that. The 11 is not actually 11. It's like 11.7 or something like that. So this is just rounded, but it is accurate. And we're just not trying to use giant numbers. To get perfect 11 degrees, we would need to use larger numbers than what we care to use right now. So we can fill this in as we go, but that's trig in a nutshell. So let's utilize this, and this is exactly what I thought was going to happen, is that we were going to cover this section very quickly. This is where we then start defining for you. Weird shot down my leg. Theta is the base angle, and it could be either angles, but we use theta as the base angle that can reference to the rise and the run. Right? If I know the rise and the run, I can figure out my theta. If I know my theta in either of these pieces, I can figure out the other piece that I don't know. And that is also trig application. Yeah.
I'm really behind on this. This is all really confusing to me.
What's confusing? I haven't even asked you to do anything.
Now, how would you use rise and run only to get theta?
Let's investigate.
What have you done, Satya?
Do you guys know how to do that?
Satya, how could you? Well, yeah, I mean, it's not that good.
So we're gonna do all this, and then you're gonna swoop in and be like, haha, math is a lie. And
Math is not a lie.
It is a lie. Everything's a lie.
All right, let's make a kind of substantially large right triangle.
Boom, 38.6 to 10. Okay. I just want to know how he turned rise and run into the angle. It's quite simple.
it's like the measurements of the
Second.
slope chart.
Tangent.
Stop. We don't just do it in a calculator.
Okay, never mind. I know how to do it. The second tangent rise over run. Got it.
No. Wrong. Wait, does that work?
You are incorrect.
Not exactly.
Right? We know this is true. We know. Because we know 45 degrees actually means a rise of 1 and a run of 1, and it fits nicely on graph paper, and that's why we like it.
It's quite nice.
Now we know this, because, bless you, because we know 90 degrees would be formed if I cloned this,
It works. Shut up, Satya.
reflected it across the hypotenuse, and then I would make a 90 by putting these together. So then we start to kind of manipulate. If I divide this, now this is where it gets a little funky. If I divide this by 2, that's not a good division by 2.
That's pretty bad.
It kind of looks like the cardinal mascot, but just the top of it.
Better, not wonderful. What's my base angle?
Half that?
Yeah, half of it, right? This is super thick. So then if that's half, we could hypothesize that this becomes half. Now, these relationships don't perfectly work because this triangle is not the same as this triangle now. Right? These are not the same triangles. So that's where we said, well, what relationship do we see is pretty close, and that's why we kind of cut this in half again and made this our 11 degrees, which it would actually be 11.25. But then this is approximately, and that doesn't work out.
That's not one.
Like now we're getting further away from like what actually works.
5'1" is not 5'2".
Right. Well,
So how did
yeah,
we get that?
but you're talking about run then rise. What do you mean?
Okay, so remember how when run was 5 and rise was 1 at an angle of 11?
Yeah.
Now run is 5 and rise is almost twice.
Now we said this is not accurate,
And
right?
also the
This is what this is where your brain's getting stuck. Is what I'm trying to show you. If we allow a direct variation
So
between,
it's not direct.
it's not.
Okay, that's freed my mind.
As your angle changes, there's not a direct variation to half the degrees is half the height. That is not a direct variation. So maybe that's just what I need to say. But here to pull in some more of like what I introed yesterday, and I want to make you guys hungry.
Lunch is literally
Lunch is
20
minutes. If you make us hungry, then we'll leave you. And go to lunch.
Do I have the sauce?
Here, you want to really have your mind blown?
No.
Yes.
This is
What
where
is
we're
this?
heading.
Yes, please.
What does that mean? It's called a reaction when a person gets mental exam.
No.
So,
No, thank you, kindly, please. Your plans to bring back communism. I'm good.
sine, cosine, unit, circle, triangle, because the hypotenuse is 1. So, wherever this falls, if we have our calculator in the right setting, like say if we type in sine of 45, we get radical 2 over 2.
485?
Sine of 45.
Oh, like the angle?
Yes.
I got negative. Why did I press my...
Now, your calculator might be in the wrong setting.
I got 2 squared over 2.
Square root of 2 over 2?
Yeah. Square root of 2 over 2.
So, if,
I got square root of 2.
Yeah, that's what I got.
yes, that's what you should get.
Oh,
So
that makes sense!
That's the length of the leg that is red right there. Because with a hypotenuse of 1 and a degree of 45, now this is not 45 degrees, but it's any degrees, right? This circle, all of this works for whatever we plug in. So then if you cosine 45 and you're in the right setting, you should get the same thing. Right? Because it's an isosceles. But if we change the triangle, make a cosine of actually, with how it looks, make it of 60. Let's make theta 60. If we do sine of 60 with a hypotenuse of 1, that leg would have to be 0.866.
How do you get into that mode?
In decimal mode, you have to hit mode and go to classic as opposed to math print.
What? How do I...
Go
How do you click
down
on it?
to
You click
classic.
Gonna enter?
Yeah, then like highlight it.
Okay.
So then, you ready? You ready? We compiled all of the nice common angle measures. I can't tell how quality these images are. You guys can kind of read that. Is there a better one? I don't know why this isn't showing you the quality.
Jumping jacks, and it's like one arm here, one arm here.
Okay, so visualize with me.
Not really.
You are not that funny.
if I make this a right triangle, this is your leg, right? Your x. And I should color code this. This is your y.
So what you're saying is, I don't know.
If the hypotenuse is 1. So from there, we can do this with any triangle we get because I can scale it, right? Once we know it's a right triangle, we can just scale to match what we have. That's what I never understood about the unit circle. That the point given the x and y coordinates are honest to God the x and y coordinates of just how far you travel here and how far you travel here.
So if we write the square root of 3 divided by 2, we get...
That's fine. That's in radical notation. Yeah. That is a way we're allowed to talk about numbers because the decimal form is ugly. It does not work well. So the radical form's better. So if you type in, let's do cosine of 30, and you're in the math print, not classic, cosine of 30, we should get the x value, radical 3 over 2, which is this distance. That's longer than 1/2. Right? Because that leg needs to be longer.
Wait, so the x value would be... So 30 divided by 2, the x value would be the square root of 3 divided
Like
by
30 divided by 2. Why are you?
Because these are 30.
Yeah, but I just said cosine of 30.
Yeah, cosine of 30.
Gets you radical 3 over 2. Why? Because that is this leg.
Because that's the rule.
That's the rule.
Why?
If we go back, because like a lot of really smart mathematicians put all this together for us. Sorry, that is what. Crap. That was what I wanted. I just need to get rid of the highlighting. We like studied enough to figure from the center with a radius of 1 if we make a circle, right? Then I can have any point on this circle and I can find how many degrees are in the theta. From there, I know the x and the y values based off these functions. So literally what's happening when you type in cosine or sine or tangent is there's a function in your calculator being applied to it. So like we would go in and type like y equals x squared plus 6x, but like a function. But these have been defined by very, very smart mathematicians a long time ago that we don't have to do it, we can use the shortcut.
Well, that's why you got a calculator.
I still don't know how to apply it to a calculator because I don't want to just type it. I want to know why it's doing it.
That's what you're doing now.
You can find moving images. I was looking for
GIF. They're actually pronounced GIF. Everyone else just GIF. Me intellectual GIF.
I'm like, going so far that way. So this uses your trig table graphic organizer, and the reason CPM is set up how it is, with like walking you to tangent so slowly, is because it breaks your brain. Right? It does. It like what Satya is experiencing is fairly common. Just back in the day, the teachers would be like, "Shut up! Stop asking questions. Memorize
I
this."
feel behind everyone else.
The rest of us are just better at internalizing our pain.
So you're critically thinking about it. Everyone else is just saying, "Okay, I trust Hudson." Like, it's not that they understand what's happening. It's just that they trust what's going on.
Except for Thomas. I think he is.
So, tangent is the weird one. And this is why we start you with tangents. Tangents, like, notice how tangent wasn't, like, if I go back to images, tangent was neither of the legs, right?
Yeah, what is it then?
Tangent, so don't think about this. So tangent literally means a line that runs, and hits one point of the circle. So it does not intersect at 2 locations. It only touches 1 point.
Oh, what?
So why does tangent matter?
So that's the definition of it.
Oh my god.
That's the definition of a tangent line. What we use tangent for, the tangent ratio we're talking about, is the ratio of the opposite leg to the adjacent leg. So, in a situation like this, where the rise is so much more than the run, the tangent's going to be larger because this ratio, this is bigger than that.
How is that possible
What
for
do you
a
mean,
line to
possible?
hit one thing of a circle?
It's like, Satya, it's like this. It's like just on top of the outside. It's not really intersecting.
Tangent.
Wow.
But you
Tangent.
always go deeper.
Nope. Not tangent. Tangent.
Not tangent. It feels
Chord.
very blunt.
Chord, right? From one point to the next, it is just in the circle. More than a radius, I don't know, no, but like tangent. Literally, you just touch. So your tangent point can move depending on the angle of your line, but if you know you have to be tangent at a certain point, connected to a certain point, like that's restricted. Right? I got to be at the right angle, or else it's gonna cut
So
through.
it's just like this.
Literally right against it, just clipping one point
So
on the
not
circle.
touching it.
No, it is just at one point.
He's touching it, not intersecting it.
I just found a paper that I think a kid just like tossed here. Because I moved my bin. Sorry, that was awkward. I'm like, what the heck is
I can't find the bin.
Wait, I think I lost the bin in my binder.
a bin? I'm gonna move on.
We are over now.
So, all of this to say, you can use your trig table, right? And that's a good start to understanding what we're doing, just relating all back to that like 11-degree situation. Or, if we want to be particular and just start doing the accurate skill, we can use the formal tangent function. Now, you have to make sure your calculator is in a correct setting, which I want to review real quick, because depending on what calculator you grab, depends on what settings it has.
I have a question. Dude, is demon a setting?
You broke your screen.
Wait,
Yeah.
demon?
Demon is.
Oh yeah, that joke. Yeah, that joke.
Is that the setting if you want it?
So why does any of this matter?
Why is funk a section? Is like
So if I roll it all up and like put it together nice, it's saving you work. Trigonometry is 3 functions that mathematicians figured out a long time ago that always hold true as long as we can input the degree measure or input the radian measure, and the radian measure actually compares the length to the length.
What
So,
about
what?
zero?
What do you mean 0?
Would zero work for
You can't have a 0 length and you can't have a 0 angle.
So it breaks it.
It just doesn't work. It just doesn't make sense. To have a triangle with a 0 leg or a 0 angle, it's not a triangle. So, right here, if you have a TI-84, or a lot of calculators have this setting,
What about TI-30X2S?
like this. Yeah, I'm looking at what the setting is in here.
This is the calculator I have.
Here, hit the DRG button. If you have a TI-30X2S, hit the DRG button. If you have the, I think it's the same.
TI-30XS?
I think it's mode in those calculators. There will be settings for radians versus degrees. Yeah, if you hit mode, it's in that menu.
Wait, there's
You want an 84 or a 30 or what?
wait, that says rad.
I have an 84.
So, if radians is highlighted like we see here on screen, it wants you to put in the value of radian measure that you have traveled, which is a certain amount of pi distance. Now, in the unit circle, I'm way over teaching this, but I want to layer it on now so it's not so bad when it actually matters for you to learn. In the unit circle, just think about this for a moment. In the unit circle, we have a radius of 1, right? What would your circumference be? That's area.
Oh! Wait, what's
Circumference, crust is Oh, you guys don't know this because I wasn't your teacher.
What's their
Memory trick for circumference that you will probably never forget.
What's their pi r?
When you eat a pie, the crust is made of pie dough.
Oh.
Crust is pie dough. The crust, it's pie dough.
2r pi.
It's dough, and then it's baked, but it's pie dough. That's your crust.
So it's just pi times 2.
That's circumference.
What?
So it's just
Crust is pi dough. Circumference is pi times d.
So it's just pi times 2.
So it's pi times 2. So radians, here's really the conversion. A radian, quote unquote, like a pi is 180 because 2 pi is 360 degrees around the rotation.
Wait,
So,
how
just hang on. You keep asking too many questions before I can even get information out, and that's why you're confused. Because so here's the issue, and I have this issue too, and I've been working on it in staff meetings. You are just listening to get your next question out. You need to listen to internalize information and then determine if you have a question. You're asking
all the time.
you're asking questions before the information is even done. You gotta stop. Don't listen to ask questions. Listen to listen, then figure out if you have questions to ask. Okay? When we look at the unit circle, what is that? What like Miss Smith has said or something?
Yeah. Like this.
Don't listen to ask your next question.
Oh,
Alright, I can't go back because my smart board hates me.
He was just waiting to ask his next question.
Oh my god.
Was he listening?
So in the unit circle,
I got it.
inside of here, because if you look this up, your radian measure is here in blue or purple or whatever you want to call that. Your degree measure is in red. You can plug into your calculator either of those, but you gotta be in the right mode. You'll know you're in the wrong mode because your answer will be all jacked up, for real. So if we try to type in a radian measure and we're set in degrees, my answer will be nonsense. Like it'll give you an answer, but it'll be like, what the heck? Oh, I'm in the wrong, oh, go change my mode. Or convert it from degree to radians. So 2 pi is 1 rotation, right? Because we know the radius is 1, which means 180 degrees, half a rotation, is a pi value. Pi divided by 2 is only a quarter of the way around the circle, or 90 degrees. And this is like actually the distance you've traveled on the arc. It's that times what your real radius is. So if we had a circle with radius of 5, right, not our unit circle, and we were asked to figure out how far we travel in a quarter rotation is pi divided by 2, but we take it and multiply it by 5 because my radius is actually 5, and it would become 5 pi divided by 2 is the arc measure of that distance traveled. Now, all of this is beyond what you need right now, but if we can get it into your brain early, it'll make more sense later when I say, okay, we have a mastery coming up. Like, that's what I'm shooting for. Because I knew today's lesson was going to be quicker, and that's why I wanted to go like down this road of a little bit of conversation with this. Cosine is always your x value, right? Your value out. Sine is always your y value. So we relate back to those. This 1/2 radical 3 over 2. Notice how it compares to this. They're the same triangle, just rotated. Right? This triangle with a 30-degree base angle and this triangle with a 60-degree base angle are the same triangle. Just turned differently. Guess what? Guess what? So is this triangle and that 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 triangle. All of those points on the unit circle are the same. You just have to determine, did I go negative in the x, negative in the y, which one gets what value? Like, do you guys see, they're all the same except for either they change locations or one becomes negative, or down here, down here, both become negative.
Did you just say downhill?
No, down here.
Oh, that's what I see.
Because both triangles are the same, they're just rotated, and some other stuff. But. So this is why I really want you guys to start like feeling that the unit circle isn't hard, because then, like, and I'm not saying it's easier for you now, but don't be like afraid of it. This is your isosceles triangle. So is that. So is that. So is that. If you have a hypotenuse of 1 in your isosceles triangle, your legs are radical 2 over 2.
Yes, a lot.
There's so many.
Questions that matter right now. Okay, actually, to go back to your homework real quick. So, you got 2 options for your homework, and I would advise using your calculator on going that option. If you want to be formal here, we know that tangent relates opposite to adjacent, but I don't have that opposite. So, yeah, here's where things start to like get a little tricky. I can use that angle of 79, and I need to figure out theta and x, right? So I can figure out theta, it's 11. But if I look at the 79, I could say tangent of 79, degree measure, right, not radian, equals 95 over x, which we know because of ratio work, I can swap my x with my tangent 79, or I can cross multiply and then divide, which will essentially swap these. So to find that x, we just do 95 divided by tangent 79. That's why, for trig, so you don't have to think through all the work of let's go to a reference sheet, let's find the degree measure that we have, or the closest degree measure to that. Let's da-da-da-da-da-da-da. Now, they, if you use your graphic organizer, are going to say, how does 95 relate to the 5? Right? Because we had a comparison of 1 to 5. So if that's times 19, this becomes 19. Now, if we do the trig, move that calculator. You get 95 divided by. I get 18.46 for the exact. So the exact, according to my trigonometry in the calculator, is 18.46. Notice how close we are. So it's not perfect, but it works pretty darn well. That's really all the time I have today. So, if you have other questions, I'll let you guys hang out for a couple minutes. So, you don't need to understand all this stuff yet, though. That's why I keep layering it on slowly. You can just use your graphic organizer if you want and just use the approximate measures. You don't have to understand the trig functions yet.
Yet.
Oh, yeah. I know, yours is so much cooler, man.
311,289 divided by.
Hey, if you want practice opportunities, Satya run away, you did run away. Khan Academy has some great practice.